Number 38, find the horizontal asymptote of the given function, and we have g of x equals x squared plus 8x minus 5 over x minus 5. So because we're told to find the horizontal asymptote, first thing we want to do is let's find out what the degree of the numerator is and what the degree of the denominator is. We can see the highest degree upstairs in our numerator is 2, and the highest degree downstairs in our denominator is 1. So we're going to use this information to find out what our horizontal asymptote is, or maybe we have an oblique asymptote. I don't know. Let's find out. So let's use the information from the chart on page 344 to see what's going on here. We're going to look at 3 different criteria. A says that if the numerator has a degree that is smaller than the denominator, then the horizontal asymptote is automatically y equals 0. Well, we can see that's not what's happening here, right? The numerator is in fact bigger than the denominator. So A is not what's happening. How about B? Well, B says if the numerator and the denominator have the same degree, then we simply take the ratio of the coefficients. Well, again, that's not what's happening here. So we can cross out B as a possibility. How about C? Well, C says if the numerator is of degree exactly 1 more than the denominator, then there will be an oblique, also known as slanted, asymptote. And that's what's happening here. We can see the numerator is 1 degree larger than the denominator. So we have an oblique, also known as a slanted asymptote, happening. How do we find that oblique asymptote? Well, we've got to use synthetic division. All right, and at this point now in the practice test, we've looked at synthetic division lots of times. We know we're going to take the opposite of whatever the constant is in the denominator. And so in this case, we're going to be using a positive 5. And let's see, make sure that we are in descending order upstairs and not missing any terms. We go from 2 to 1 to none, so it looks like we're in good shape. We can go ahead and bring our coefficients down. Coefficients are 1, 8, and our constant, -5. And now we can start. We'll bring that positive 1 down. We multiply. 5 times 1 is 5. Adding vertically, we get 13. Multiplying 5 times 13 is 65. And if we add vertically, we get 60. All right, when you're dealing with your oblique asymptote, we are not interested in the remainder at all. So go ahead and just ignore that remainder. What we're interested in is the quotient. And remember, this is the quotient, except it's missing the x term, so we've got to fill them in. If the highest degree that we started with was 2, we drop 1 and start filling in. All right, so we drop 1, which means we go from 2 to 1, and then from 1, we go to none, right? So what happens here is, and that was a positive 13, right? 8 plus 5 is positive 13, is we're left with y equals x plus 13 as the equation for the oblique asymptote, all right? So again, if the degree of the numerator is 1 larger than the degree of the denominator, you have to perform synthetic division, and whatever the quotient is of that synthetic division when you actually divide is going to be the equation of the oblique asymptote. So whatever the quotient is, simply put y equals that quotient, and that's the linear equation of your oblique asymptote. So in this case, number 38, y equals x plus 13.